Hello. In this video, I just want to explore the difference between an identity and an equation. So an equation, by the way, to me, they both look the same, right? They have an equal sign between two statements there. So I have an equation is really true for only some inputs, not all inputs. So in this case, for example, x plus 4 equals 10. You could try certain inputs like 2, but 2 plus 4 would be 6. 6 is not equal to 10, so that's a false statement. If I put in 6, 6 plus 4 is 10, so that's a true statement. But as long as I find one input that doesn't work, it's just an equation, it's not an identity. So an equation is true for only some inputs, so -5, false statement, right? Now it can be that you have more than one input that makes the statement true, but it doesn't matter how many inputs make it true. If there's one that makes it false, it is not an identity. So just in contrast, an identity is true for all inputs. So for example, here x squared equals 25. Both +5 and -5 make the statement true, but x equal to 1 doesn't. So this is an equation, not an identity. Now in contrast, an identity is true for every single possible input you can put in there. So if you can find even just one that makes the statement false, then it is not an identity. So here's an example. Sine of the negative of an angle is the same as the negative of the sine of the positive angle. Now, when I say theta, theta could be negative or positive. It's just that do I put a negative in front of it or not? It's all the same here. So for example, if you look at 30 degrees, and I'm using degrees only because it's perhaps a little more familiar. Here's 30 degrees. The sine is 1/2. So I'm saying here the sine of 30 degrees is 1/2, and then I take the negative of it. And that's the same as if I just look at the sine of the negative of the angle. Well, if I look at 30 degrees and I go -30 degrees, then I'm here, and the sine is -1/2, right? So I just have -1/2, so that's correct. If I try -pi/3, for example, so that means that theta itself is -pi/3, right? So that's here. So if I look at the rotation, I'm here at -pi/3. There I am. The sine is -√3/2. Okay, and then I take the negative of that, of the result that I get there. So a negative of negative is a positive. Now if I compare that to sine of the negative of theta, that would be negative pi/3. That would be +pi/3. That means I would go this way, +pi/3, and there I am, √3/2. So that's correct. So basically what I'm saying, what this is saying, and this is in another video, is that when I rotate, right, whatever I rotate, I'm looking at the sine, which is the y coordinate. And so if I rotate this direction, the y is positive. If I rotate this direction, the y is negative, but it's the same length. So one is just positive, one's negative. If I rotate more, I go into quadrant 2. Here the y is positive, but then if I start here at 0 and I rotate the same amount, but going this way, and the angle's negative, the y value, the y coordinate is negative. That's all that's saying. And now let's take a look at one more identity that is incredibly important. Sine squared plus cosine squared is 1. And I'm telling you, this is an identity. This works for everything, for every input you could possibly think of. So I tried a couple of them. I showed you that at theta at 30 degrees, right? The sine is 1/2, the cosine is √3/2. When I square both of them and add them, I get 1. At 240 degrees, I'm here. The cosine is -1/2, the sine is -√3/2. So I square them both, and I add them, I get 1. Now I'll just go a little further and actually show you that in the calculator, I put this in the calculator. And notice, by the way, the square applies to the function, not the angle. So what I mean by that is, oops, sorry. If I had meant to square the angle, I would have to have written it like this. Okay, in that case, the square applies to the angle, not the function. But this is the square applies to the function. And that's why I input it the way it did. And then I have set up the table. So it starts at 0. And by the way, I'm in degrees. I'm in degree mode. And that's just for, again, ease of being able to recognize it more than anything. And I'm incrementing by 1, and when you actually see what do you get, no matter what I put in, the result is 1. Okay, it's just 1. And let's say I go increment by larger amounts instead of just 1. Let's say I increment by 30 degrees. And look at the table. And see, I can go all the way around the circle. And I still get what? 1. All right? So it doesn't matter what input I put in here, I get a true statement. So that is an identity. Thank you so much for listening.